30 or bigger. Because like in that bunny picture, it said, if you have bunnies of 5 or bunnies of 10, it's going to vary greatly. But if you have sample sizes of 30 or more, that's a good size. Okay? And then we'll talk about 8.2 a little bit in a minute. And if we are doing Z and X are the same thing to find Z or X, we're going to do inverse norm the same way we've always done it, area to the left, mean and standard deviation. And I'm going to do several of these examples so that you don't get lost. We just watched those videos. Let me see. They talked about this in the video. For any population, regardless of how the shape started out, as the sample size increases, the shape of the distribution of the sample mean becomes more normal. So if I increase the sample size from 50 to 100, it's going to become more normal. If I increase the sample size to 500, it's going to become even more normal. The more people you ask, the more they're going to start answering what you want them to hear. All right, let's start doing some problems. All right. This one is just a question making sure you understand the terminology. Suppose a simple random sample size of n is drawn from a large population with a mean of n and a mean of mu and a standard deviation. The sampling distribution x bar has a mean. So no matter what, whether it's individual or whether it's group data, what is the mean always going to be? The same thing. The mean is going to be the mean. And the standard deviation is going to be. So y'all, we have a group of people. So am I fat? No. I sucked in, and what did I do? What is my new standard deviation going to be? My old standard deviation divided by the square root of n. So if it was just one person, my standard deviation would be that. But because there's a group of n people, I'm going to take whatever size I was and divide it by the square root of how many people are in the picture. And the more of these you do, you'll understand. The standard deviation, I don't think we talked about this one, the standard deviation of the sampling distribution of x bar, sigma x is called the standard error of the mean. And I think the first guy mentioned this a little bit, and we'll talk about this more. Even though it's not error per se, they didn't make a mistake, it's that every time that you sample another group, it's going to vary a little bit from the mean. Some's going to be above, some's going to be below, but all of those are going to be a standard error of the mean. It's going to be a little bit above and a little bit below. All right. Determine the mean and determine the standard deviation. We have a original mean of 80, a standard deviation of 14, and a sample size of 49. So, we're doing group, the size is 49. So, what is my mean going to be? What is my new mean? 80, because your mean never changes. What is your new standard deviation? Tell me what I need to write.
14.
Your old standard deviation divided by how many people are in the picture. So I was a size 14, and we throw 49 people into the picture. Y'all, throw them in there, because now I am looking like a size 2. Throw them in there. So this is group data. You're taking all these samples, and my standard deviation is now 2. So if this was a single piece of data, my standard, which is what we did in chapter 7, your standard deviation was 14. But now that we got all these groups in there, it's getting all this squished up, I have a new standard deviation. So my new standard deviation is going to be 2. There's it written out all cutesy. All right, I want to know the new mean and the new standard deviation. The new mean and the new standard deviation. New mean and new standard deviation. Rachel, what's my new mean?
52.
52. My mean does not change. My new mean is my old mean. Now, this is telling me that we have a group. You got a group of people. So we're saying suck it in, turn sideways. So my new standard deviation is going to be my old standard deviation divided by the size of the group. So what is my old standard deviation? Divided by the square root of 21. So in my calculator, if I was standing alone, I look like a size 10. Throw some people in there with me, I now look like a size 2.2. So my new standard deviation is a 2.2 or whatever they want me to round it to. Cool? All right. Answer the following questions for the sampling distribution of the sample mean to the right. What is the value of the mean? We know the mean is here. 500 is the mean. What is the standard deviation of the sampling of the means? 20. Okay? So, my first answer is going to be that my mean is 500. Oops, let me change colors so I can. My standard deviation is going to be 20. If your sample size is 16, where did I lose the rest of my question? Huh. Grab a book and see what the rest of the question is. I snagged and did not snag everything. 8.1, number 13. What is the likelihood about the shape of the population? If the sample size is n equals 16, what is likely true about the shape of the population? What's likely true about the shape of the distribution? What's been true about all our distributions?
There's normal.
It's going to be normal. All of our distributions have been normal. Let's see if I put D in there. A, B, and C. Did I not copy my D either? What the hell sandwich? Let me write down my D. If the sample size is n equals 16, what is the standard deviation of the population from which the sample was drawn? So if the sample size was 16, what is the standard deviation of the population from which the sample was drawn? How would I do that? Love you. So they're telling us that what is our new standard deviation? Okay, where does the 16 go? Under the square root, because that's our sample size. Now, what other number do we know? The 20. Where does the 20 go? Is our, we're trying to find the old standard deviation. We're trying to find like the backward standard deviation. So what are we going to do to get x? Multiply both sides by square root of 16, and we all know that the square root of 16 is 4. So I'm going to multiply both sides by 4. So what was the original standard deviation?
80.
80. I'll give y'all some to work in just a second. Let me move down and I'll show you. So they wanted to know the original standard deviation. What was my original size? If my new size, the new standard deviation was 20, and it's going to be 80. All right, let's find one for y'all to do. Lay a little cover up. Bless you. All right, for this one, they want you to talk about the new mean and the new standard deviation. The new mean and the new standard deviation. The new mean and the new standard deviation. James, what is my mean going to be? 80. My mean does not change. So my mean is my mean is my mean. My mean is going to be 80. Courtney, how do I get my new standard deviation?
You put the old standard deviation over the square root of n.
So what is my old standard deviation?
2.
What was my old standard deviation?
Oh, the old one is 14.
divided by the square root of,
49.
so that's 14/7. So my new standard deviation is going to be 2. And when you're doing these on the test, y'all, you're gonna have to say, you know, what am I gonna be doing? Well, if they're giving you n, if they're telling you the sample, how big is the sample size, that should be screaming to you that you've gotta divide by the square root of n. There's a lot of people in the picture, let me make myself skinnier. That's gonna be, and your mean is always gonna be your mean. So you're gonna have to divide by the square root of n. So my mean is 80 and my new standard deviation is 2. Because your n is greater than 30, we know that it's going to be a normal. All right? Let's look at this one. What is the probability that x bar is greater than 83? We are doing probability, so what are we trying to find? The shade. We're trying to find the shade. So we are going to do a normal distribution. What did we say our mean was? 80. What did we say that our new standard deviation was? 2. That came from right there. And we are doing that 83 or greater. And we want to know the probability, and because we're trying to find the probability, we are going to do the shade. So we're going to use what? Normal CDF. So, when we do normal CDF, we're going to do, where does the shade begin? 83. 83?
82.
83. I didn't write it right.
Okay.
83, where does the shade end? 99999. What is my mean? Now, the way that I got my standard deviation is because it is group data. I took the old standard deviation, which was 14, divided by the square root of the size of the group. So, you can either type in this, or you can just type in 2. Because I'm not always going to give you that question above. So if you want to, you can go to your calculator. I mean, it's up to you. So I can even do second bars, normal CDF. I started at 83. I went to 99999. 80 was my mean, because that's always what it is. And then 14 divided by the square root of 49, and I make sure that I close those parentheses because I'm telling my calculator that 49 is the only thing that's in the square root. And just to show you, if you would have done, come on, if I would have done second enter and back that thing up, and delete it out. Oops, I deleted out a little too much. And done comma 2, I would have gotten the same exact answer. So if you want to put the answer to the new standard deviation, that's fine. Or if you want to type in the standard deviation, that's fine as well. Does not matter.
Doesn't that get you greater than or equal to 83, not greater than 83?
Is the approximate.
So I think CDF is greater than or equal to or less than or equal to.
Good question. Let me look into that. Let me look into that. Good question. All right, let's look at this one. What is the probability that x is less than or equal to 75.8? What is the probability that x is less than or equal to 75.8? Our mean was 80, and our new standard deviation was 2. So really the only difference, y'all, this is that group data. We're doing those samplings, so we're doing those groups, so we have to divide by the square root. That's the only difference, so we're doing that extra step at the beginning. There's my 75.8, and we're doing less than. We are trying to find the probability, which means we're trying to find the shade. Where did I start? Where did I end? What is my new mean? And what is my new standard deviation? And you could use that, or you could use the 14 divided by square root of 49. We've already said they'll give us the same answer. And there's going to be my final. So 1.79% is going to be shaded to the left. All right, one more out of this one. We have our mean of 80, our new standard deviation of 2, and this time we're doing a between. So because we're trying to find the shade, it's going to be a normal CDF from 78.3 is our begin, 85.1 is our end, 80 is our new mean, and 2 is our new standard deviation. I'm going to move this up so that we can have it all together. Cut. And paste. And like I said, I have to draw every time, some of y'all don't, but I draw every time to make sure where it starts and where it ends. And this is our old standard deviation divided by the square root of the size of our group. And on your test, if it says the sample size is blah, 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 that is screaming that you need to suck it in and find that new standard deviation. All right, I'm going to walk around and look at the next one. Let me cover up before I walk around. I build you up to tear you down. Good job. Oh, Josh. Perfect. Get to me. That's perfect. Perfect. 400 of these. Perfect. Got to let the problem lead you. Got to be one with the problem. We have a normal distribution with a mean of 266 and a standard deviation of 16. Does it give us a sample size? Do I have a bunch of people in the picture with me, or is it just me? It's just me. It doesn't say there was N equal 40 or 20 pregnant women or whatever. It doesn't give us a sample size. So we don't have to get a new mean and a new standard deviation. It is what it is. The standard deviation is what it is. This is chapter 7. This is what we did 400 problems of. This is chapter 7. There is no N. So this is less than 260. Find the probability, which means we're finding the shade. So this is a normal CDF. My left shade is negative 9999. My right shade is 260. My mean is 266. My standard deviation is 16 because I have nothing to divide it by because I have no sample size. This isn't old school. It is what it is. I'm a size 16. Don't suck it in because there's nobody else in the picture. There's my answer, 3538. 0.3538. Alright, this is back from, I'm going to clone. Alright, the original problem says you have a normal distribution with a mean of 266 and a standard deviation of 16. What is the probability that a random sample of 20 pregnancies has a mean gestation period of 260 days or less? I'm going to come around and look. I usually go 4 places behind. Or you can type the whole thing in. I could have just looked at Paris. This is halfway through. Be back on it now.
I had a carrot 26 instead of 16 for.
Really?
Yeah.
Oh my word. Yep.
She also could have done this.
When you did, yeah, when you did, when you did that, you could have done